All right, good afternoon, everybody. Or, yeah, good afternoon. So at the end of the last lecture, we were talking about arrays and how to copy an array. So remember in C, you can't assign to an array variable. Okay, so back here, I've got an array of car. And str2 is also an array of car. Right? These both represent C-style strings. It's often convenient to be able to copy a string. Excuse me. So you'd like to be able to write something like that. Unfortunately, you can't in C. If you try to do that, you get an error saying assignment to an expression with array type is illegal. Right? You can't assign to an array variable. And str1 is in fact an array variable. So that doesn't work. So you have to copy, in this case, the two strings or the contents of the two arrays. You've got to do this yourself manually. Right? And so there's a loop that copies the elements of y into x. Right? It's just a straightforward loop over the elements of the array you want to copy it into the destination array. Right? If you do that, you actually get a copy of y. Right? So x becomes a copy of y. If you want to copy an array, memcopy is generally easier to use. It's certainly easier to write as soon as you get used to the pointer syntax that memcopy uses. Right? And so in memcopy, what you need to remember is that you're going to copy from the source array, so that's the second argument, into the destination array. Notice that the source array is marked as being const. So memcopy is trying to tell you it's not going to change the contents of the source array. Right? So if you ever see an array, or in this case a pointer, marked as being const, it's trying to indicate to you that the function does not modify that particular argument. Right? So whatever your source array is going to remain unchanged. Now your destination, notice that that is not marked to const. So this is trying to tell you, hey, it's going to write into the destination array, probably changing its contents. What the function cannot do is it cannot change the size of the destination array. Right? So the array is still an array. It looks like a pointer, but it's actually an array. I'm going to explain this pointer syntax in a moment. Right? So the contents of the array can be changed, but the array itself cannot be changed. And then finally, what you need to remember is that count is not the number of elements to copy. Rather, it's the number of bytes to copy. And remember that in C, bytes are simply 1 byte is equal to the size of a card. Right? So size of card equals 1 byte in C. A byte is not necessarily 8 bits, right? So if you're used to thinking of a byte's always 8 bits, that's not really the case. The byte is a term for the size of the data type on your computer that has a size defined to be equal to 1. So it's not necessarily 8 bits, right? Never mind, that's not that important, right? It's the size of, it's the total size of memory that you want to copy, right? So if you want to copy, in this case, an array of 3 ints, when you use memcopy, you need to compute how much memory does 3 ints occupy? Well, it's 3 times size of int. Right? Remember, size of always returns a value that are in terms of multiples of the size of car. Right? Size of car is always equal to 1. I want the size of int on my machine. I think it's equal to 4. 3. Yes, I think it's equal to 4. So this will copy 12 bytes of memory. Right? From there into there. Right? And if you run that code and print out the resulting array, you do in fact find that the elements of y have been copied into x. Right? Now, that pointer and that pointer, they don't have to point at the start of the arrays. Okay? So in other words, you can copy from the middle of an array into the middle of another array. All you have to do is adjust the pointer. Right, so by adjusting src and dest, you can copy into different parts of the array. Okay, so here X has 6 zeros in it, right? And Y has 10 numbers in it, 10 through 19. Okay, so I need, so I'm going to, in this example here, starting at the 5th element of Y. So 0, 1, 2, 3, 4. So starting at the 14, right? That's the element where I want to start copying out of Y, right? So the address of that element, right? Remember, I need a pointer, right? Is the address of Y4, right? So address of Y4 means the pointer that points at that 14. I guess more precisely, it's the pointer that points into the array Y and happens to be pointing at this 14. Right? Now I would like to copy into array X, right? Starting at the 3rd element of X, right? So that's the address of X2, right? So 0, 1, 2, so here, right? The address of X2 is the address or is a pointer to that 0 there in the array X. Right? Now I would like to copy 4 double value out of Y into X, right? So I'd like to copy the 14, 15, 16, and 17 into the 3rd, 4th, 5th, and 6th locations of X. Right? So source, right? Pointer to the 14. That's just the address of Y4. Right? Destination, pointer to the location where I want to copy into. So that's I want to copy starting in. I want to copy into destination starting there. So that is the address of X2. I'd like to copy 4 double values from Y into X, right? And if you run that, implicit declaration of memcopy, fine. This needs a, or this wants an include string. Yep, that's for memcopy because memcopy is declared in string.h. And so now you can see when you print out X, right? The first 2 elements remain 0, and then the next 4 elements are the elements that were copied out of Y. Okay, so C strings are represented using arrays. They use the null character. Remember, the car equal to \0 to indicate the end of the string. Right now, you can use memcopy to copy strings. It works exactly the way you would expect it to. Right. However, there's a special function called strcopy that's more convenient to use. Right. So string copy copies an entire string into another string. Right. You can't specify. Sorry, I lied. You can in fact specify. You can in fact copy a substring into another part of another string. Right. String copy is a little bit easier to use. Generally, when you're copying strings, you want to copy the entire string. Right. Remember, in C, you don't know how long the string actually is, so it's hard to write this part for memcopy. Right. If you don't know how long the source string is, you either have to compute the length by calling a function, right? But it's easier just to use string copy because string copy will just copy to the end of the string, right? How does it know it reaches the end of the string, or how does it know when to stop copying, right? When it finds the character equal to \0 in the source string. Okay, so when we talk about strings, we'll look at string copy and how to implement it in that notebook there. All right, finally, I think this is the last part. Is this the, it's not. Okay, so it's quite a bit more. All right, so when you're using arrays, especially when you're calling a function that appears to need an array as one of its inputs, you'll often see a pointer instead of an array. And so the idea here is that in C, if you have an array called ARR, right? So I have a variable called ARR, so one right here, right? ARR is an array of 3 doubles. Right? If I just use the name ARR itself, right, then that's equivalent to a pointer to the first element of ARR. Right? So first element of ARR, if I take the address of all of that, right, that gives me the address of that one in memory. Right, that's an address, so I can store that in a pointer of the appropriate type. Right, so P is a pointer to double. It points at the 1. Right. If I use just the name ARR instead, right, that's equivalent to the pointer P. Right, so the name ARR is just the same as a pointer to the first element of the array. So if I write if P equals ARR, that should be true. And I should get P equals ARR in the output of this program. And I do. Right. So the name of the array, just a pointer to the first element of the array. So what does that mean? So remember, you can't assign an array variable to another array, an array to an array variable, right? But what you can do is you can assign a pointer to a pointer. Right. So here, I've got my array str. Right. It represents a C string equal to sys220. Right. Here I've got a pointer to car. So I'm allowed to point, using this pointer, I can point at any of the characters in str. Right. If I want to, I can point to the first character in str by writing P equals str. Right. If you want to, you can write P equals address of str0. It means the exact same thing. Right. But it's a lot harder to write. And so this is a lot easier to write. Now, what does this mean? Do you have 2 arrays? The answer is no. You still have 1 array. Right? You have 2 pointers, though, to the first element of the array. Right? You got str. Right? That name is the pointer to the first element of the array. And now you've got P, which also points at the first element of the array. Right? Remember, you only have 1 array. If I dereference P, right, P points at the first element of the array. So in this case, C is equal to the capital C. Right? Dereference the pointer, that gives me the object being pointed at. Right? So the object that we're pointing at is the first character in the array, which is the capital C. Right? If you print that out, right? So if you print out so first of all, if you print out the P, remember that's a pointer, right? But when you use printf and you tell it to treat that value as though it were a string, right? It assumes that your value P is pointing at a string of some kind, right? A character in a string of some kind, right? And so that just prints out the string, in this case, sys220, right? And when you print out the character C, well, that's the big C right there, right? The first character being pointed at. Okay, now if you go so you can assign an array to a pointer, but you can't go the opposite direction, right? You cannot assign a pointer to an array variable, right? Array variables are not assignable. So here, str is an array variable, right? Str square bracket, it's an array of car, right? There's my another array of car. I would like to copy the contents of str into copy. Right. So I know that I can take a pointer to the first element of str, right, by writing car star P equals str. Right. That's a pointer. So can I store the pointer into the variable copy? Right. After all, copy. I just told you copy is equivalent to a pointer to the first array, to the first element of the array, right? And it turns out that doesn't work, right? So if you try to cheat this way, the compiler doesn't allow this to happen, right? Again, it says, hey, you're trying to assign to an expression with array type, right? You're trying to assign to copy, which is an array. You're not allowed to assign to an array, right? So that doesn't work. Okay, so if the name of an array variable is equivalent to a pointer to the first element, right? Is it possible to get a pointer to, say, the second element, or the third, or the fourth, or the fifth, or so on, and so on, right? Well, obviously, you can use the square brackets, right? Because we've been doing that all along. Right, so if I want a pointer to the second element of the array, I can write ARR square bracket 1, and then take the address of that. That's fine, right? That's awkward to write, right? It's inconvenient. So what the C language lets you do instead is it lets you treat that index, it lets you add that index to ARR. Right? So in other words, if I had written double star P equals ARR plus 1, right? Then the compiler treats that as though you had written that instead. Right? So if you have a pointer that points into an array, say it points to the first element of the array to keep things simple, right? Then p plus I, where I is some integer, some unsigned integer, is a pointer to the element. Oh wait, this is more general than I should have done. Okay, so p is a pointer to the element at arrj, right? Then p plus I is a pointer to the element at arrj plus I. Right? So if p is a pointer to an element of the array, p plus I is just a pointer to the element that's I positions down from p. Right? Similarly, p minus I is just a pointer to the element that's I positions to the left of p. Right? And so you're allowed to do what's called pointer arithmetic. You can also use pointer arithmetic in dereferencing. Right? So if p is a pointer to some element arrj, right, then p plus I is a pointer to element arrij plus 1. Right? If I dereference that, right, that's exactly as though you have accessed the element at arrij plus I. J plus I, that's right. Okay, so let's look at an example of this because that was a bit too general, the description I had written up there. Oh, this one's a little too general too. I should have started out at P0. Let's do this a different way. No, I guess we're doing it this way. I'm going to have to change too much code. All right, so I'm going to start out with an array of 7 elements. Right, for convenience, the elements are just equal to their indexes. Right, 0, 1, 2, 3, 4, 5, 6. ARR3 is the 3, right? The 4th element of the array. Right. If I take its address, I can store it in a pointer to double, like that. Right. Okay. So p points at that element there. Right. P plus 2 points at the element that's 1, 2 positions down. So it points at the 5. Right. If I dereference that, that should print a 5. And it does. Right. Okay, so p points at the 3. Right. P minus 3 points at the element 3 positions to the left. Right. So 1, 2, 3. So it points at the first element of the array, which is in fact 0. Right. Now remember, the name of the array is equivalent to a pointer to the first element of the array. So if I write ARR plus 6, right, that goes to 0, 1, 2, 3, 4, 5, 6 positions down, right? And if I dereference that to get the value and set it to minus 100, right, that changes the last element of the array to minus 100. Right? So instead of using square brackets to access elements of an array, you can always use pointer arithmetic. Right? ARR, right? ARR0 is that element there. Right? ARR plus 0 is a pointer to that element. Right? ARR square brackets 1 is that element there. Right? ARR plus 1 is a pointer to that element. Right? And so on, and so on, and so on. Right. So pointer arithmetic turns out to be very handy. It lets you write code, especially code that runs over an array. It lets you write it using pointer arithmetic instead of using array indexing. Okay, so given an array of length n, so here we have an array of length 7. The C standard says you are allowed to take a pointer to the element 1 past the last element. Right, so I can write ARR plus 7 safely. Right, remember that's plus 0, plus 1, plus 2, plus 6. Right, plus 7 would be the element after the 7. Right, so the pointer to the element 1 after the last element in an array is called the too far pointer. Right, and the standard says that pointer always exists. Right, it also says you can't use that pointer for anything safely. right? So don't try to dereference that pointer, right? There might be something else sitting there, right? There could be another variable sitting after the array, right? Which you should not overwrite, right? But the standard says this pointer does actually, that pointer exists and actually points at something, right? Now, the reason that pointer exists is because there's a lot of old C code kicking around that relies on this pointer existing, right? And so when we get to this section here, you'll see exactly why the too far pointer has to exist, right? If it didn't exist, you could not iterate over an array of elements using a pointer safely, right? You'd fall off the end of the array and then bad things would happen. Okay, so if you can do addition and subtraction with pointers, can you do other arithmetic computations? The answer is yes, right? So for example, you can compare two pointers, right, for order, right? Now this only works if your pointers both point into the same array, right? If you have two arbitrary pointers, then the comparison's meaningless, okay? So as long as your pointers are both pointers in the same array, right? So you have P and Q, right? Then that means, right, if P points at ARRI, and Q points at ARRJ, right? Then if P is less than Q, right, that simply means I is less than J, right? So in other words, I guess a picture would be more useful here. Right, so if you imagine an array of elements, right? Then the situation where P is less than J, P is less than Q, right, simply means P points at an element that's in front of Q, right? So here P is less than Q. It doesn't mean the elements being pointed at. It doesn't say anything about the elements pointed at, right? So this was an array of int. This could be 100, and that could be 1, right? It doesn't tell you anything about the 100 and the 1. It simply tells you what is P pointing at relative to Q, right? P is pointing at an element that's in front of Q, right? If P is greater than Q, then P points at an element after Q. So I guess I'll just draw it down here. Q, P, well, that's P is greater than Q. Right. Again, it doesn't say anything about the elements being pointed at. It just tells you what are what is the relative ordering of the locations of the elements using P and Q. Right. P points at an element after Q. Right. If they're equal, P and Q are equal, and that says P and Q both point at the same element. Okay. So P and Q are both here. Right. Then they're both pointing at the 1. So remember, you can also do that for any two pointers, P and Q, right? If P equals Q is true, then either you're pointing at the same element or they're both pointing at null. Right? So you can also compare pointers for order. All right, so how am I going to use a pointer instead of an array index? So the way you use a pointer instead of an array index is you typically end up using plus plus minus minus plus equals or minus equals. Right? So plus plus advances the pointer 1 position to the right. Minus minus advances the point, I guess moves the pointer back 1 position to the left. Right. P plus equals n moves the pointer n positions to the right. Right. P minus equals n moves the pointer n positions to the left. Right. So if you want to iterate over an array using a pointer instead of an index, right? Make your loop variable a pointer. Right. So here P is going to be a pointer to the first element of ARR. Right. When do I want to stop? When do I want the loop to run? Right. As long as P is less than ARR plus 7. Right. ARR plus 7 is the too far pointer. That's ARR. Right. ARR plus 1, plus 2, plus 3, plus 4, plus 5, plus 6. Right. ARR plus 7 is over here somewhere. Right. The standard says that pointer exists, so you can safely use it in a loop like this. right? If the standard says you can't take a pointer to any element outside of the array, you can't write the loop like this anymore, right? And there's a lot of C code kicking around that does exactly this, right? Each time through the loop, I would like to move to the next element, so I can write P++. Inside the loop, I'm simply going to print out the value that P is pointing at. How do I get the value that P is pointing at? Dereference the pointer, right? Star P. Dereference the pointer to get the double value pointed at, and I can print that out using %f. Right? If you want to go backwards, you just start at that element there. Right? What's the pointer to that element there? It's ARR plus 6. So starting at ARR plus 6, right? As long as P is greater than or equal to ARR, right? So in other words, as long as P is pointing at any one of those elements there, you could also write P is not equal to ARR. That would be fine as well. Right? Decrease the pointer by 1. So go backwards, or move the pointer 1 position to the left. Right? So going forward, you get 0, 1, 2, 3, 4, 5, 6. Going backwards, you get 6, 5, 4, 3, 2, 1, 0. Right? And so instead of using an index, you can just use a pointer instead. All right. So why do you need to do this? Well, you never have to do this, right? If you want to, you can always use the square brackets to index into an element of the array. Right? Now the problem is when you try to write a function that requires an array as one of its parameters, right? The compiler doesn't actually, so you can safely write void f into ARR square brackets. That's fine. The compiler doesn't actually treat ARR as though it were an array. Right? What it actually does is it says ARR is just a pointer to an element of this type. Okay? And so we say that an array, when you pass it to a function, actually decays to a pointer to the first element of the array. And so it uses the fact that C considers the name of the array to be the same as a pointer to the first element of the array. Right? So if you write that function there, in reality, what you get is this function here. Right? One of the reasons this happens is because you generally don't want to pass an entire array to a function. Right? Remember, arrays can be arbitrarily sized. Right? If C lets you pass an array to a function, what would end up happening is you'd have to copy all the elements of the array and give it to the function. Right? So instead, it's much easier simply to pass a pointer to the first element of the array. And now you can use pointer arithmetic to access any element of the array that you want. So now one of the implications of this happening, right? So this is important, right? Is that it is impossible to determine the size of the array that you've passed the function. Right? Cannot do it. Right? If you write that function there, right, you need to assume something about ARR, right? So when you're writing the function, you either need to assume that ARR has a known length that you know, right? So it has length 10, and inside your function, you're going to assume it has length 10, right? Or there has to be some special value in the array that indicates the last element of the array, right? So that's how strings work in C, right? There is a null terminator character \0 that indicates the end of the string. Right here, you might use, I don't know, -1 to indicate the last element of the array. That's problematic, right? Because that means your array can't have the value -1 as one of its ordinary elements. Now it's marking the end of the array. Right? So typically what you do when you write a function like this is there's a second parameter that is the size of the array, right? The number of elements in the array. Whoever's calling the function needs to know how big an array they have. Okay, so if you remember back to the first time I introduced arrays, right? So when you make a little local array, you can play this trick. Right? So if I had a local array called ARR, you can take the size of ARR and then divide it by the size of the element type, and that will give you the number of elements in the array. That doesn't work in this case. Right? Remember, the compiler is treating this as though it were a pointer to int, right? Even though you wrote ARR as an array. right? The compiler thinks it's a pointer. So when it computes the size of ARR, it computes the size of a pointer, which is always a fixed size on any computer, right? On my computer, it's going to be 8. Right? So if I run this, you actually get a warning, right? So at least my version of the compiler is warning me, right? It's telling you, hey, you're trying to do size of on an array function parameter, right? And it's even telling you, right? It's saying, I'm going to return the size of a pointer to int. I'm not going to return the number of the amount of memory used by the array, right? Notice that the calculated length of the array is 2, right? Size of int on my computer is 4, right? Size of a pointer on my computer is 8. 8 divided by 4 is 2, right? Notice the length of the array that I'm actually passing in is 100, right? So that does not work at all to compute the size of an array passed to a function. Right? That's why the notebook that tells you how to do this says never do this. Right? You never want to have to be in the situation where you need to compute the size of the array. Right? You probably can't do it reliably. Right? So when you're writing a function that requires an array as one of its parameters, you have to do something extra when you write the function. Right? Either you require whoever is using the function to tell you, hey, how long is this array? Right? So you need an extra parameter. Right? Or you have to reserve a special value that you're going to use to indicate the end of the array. Right? Again, for strings, \0 or the numeric value 0 is used to indicate the end of the string. Right? So here's an example of the function max, computes the maximum element, the maximum value of the elements in an array ARR. Right. So there's my input array. Notice it's marked const. So max is trying to tell you I'm not going to change any of the elements in ARR. Right. It's an array. ARR is an array, but remember the compiler is going to treat it as though it were a pointer. Right. To use this function, whoever is calling the function needs to know how big is the array. So they have to pass in a second parameter, which is equal to the length of the array. Right. And now this now max knows how many iterations can the loop run, right? How many elements in the array do I have to look at before I know the maximum value? Right. So in C, there are no zero-sized arrays, right? So you can, if you pass in 0 here, sorry, you are not supposed to pass in 0 here because there are no zero-sized arrays in C. Right? If you have an array, it's always at least of size 1. So you can always write that. You're supposed to be able to always write this safely. Right? So I can always look at the first element of the array. And now I just loop over the remaining elements of the array looking for the maximum element. Right? So it's the standard max loop. Right? Does it work? Yes, it works absolutely. Right? Max is 99. Now, of course, if someone calls the function with the wrong value of length, all bets are off. Right? So for example, if someone calls the function max with the length equal to 1, it's simply going to compute the maximum of one element in the array, right? So because the loop here is going to stop after, it's never going to run because it starts looking at the second element in the array, right? So that's going to give you back -5, right? If someone passes in 2, it's only going to give you the max of -5 and 5, right? And so on and so on, right? So the max of 3, we'll look at the max of the first 3 elements. And so on and so on and so forth. If you pass in a value that's too large, so 1, 2, 3, 4, 5. So if I pass it in 6, let's see what happens. Okay, it ran, but notice you got a strange result. Right? So that's a weird result. Why do you get 32,767? Because whatever value is sitting after the 8 in memory on my computer happens to be 32,767 when you interpret it as an int. Right? Notice you don't get an error. Right? There's no indication that you've fallen off the end of the array. Right? If you don't know what elements are in the array, right? So if I didn't know the maximum value is 99 here, I would mistakenly think the maximum value is 32,767. any other operation I use using the max is now going to be wrong, right? And I won't know there's a problem until something else later down the line, until something else later down the line doesn't work the way I expect it to, right? And it's not until you trace the problem back to here where you realize that you've fallen off the end of the array, right? There's no way for the writer of max, right, to detect that they've fallen off the end of the array, right? So here the fault lies with the caller, right? A lot of people argue the fault lies with the language, right? The language shouldn't allow this to happen, right? Which is why in Java and Python and many other modern programming languages that are safer than C will try to prevent this sort of thing from happening, right? If you try to go past the end of an array in many languages, that'll immediately cause an error of some kind, right? C and C++, that doesn't happen. Okay, so if you pass an array to a function, it's really a pointer to the first element. The same is true if you try to return an array from a function, right? If you return an array from a function, you're returning a pointer to the first element of the array. Okay, so, right. So what's the problem if you are returning a function, an array from a function, right? Remember, the caller gets back a pointer to the first element of the returned array, which means they don't know how big is the returned array, right? That kind of sucks. So if you're writing one of these functions that returns an array, right, then you need some way to tell the caller how big is the returned array, right? Problem number two, a C function can only return one value. So if you're returning a pointer to the array, you can't also return the length of the array. What do you have to do? You need to add another parameter to your function, right? Where the caller passes in the address of a variable where you can write the length of the array into, right? So typically what these functions look like, there's a parameter that's a pointer type, usually pointer to size t or a pointer to int. The function writes the size of the array into that object, right? What else can you do? Well, this one here, right? You can return an array, or the array contains a special value that indicates the end of the array, right? So if you have a function that returns a string, well, one of those values in that array is going to be \0 to indicate the end of the string. You have more choices, right? Instead of returning an array, return the length of the, instead of returning the array, you can return the length of the array, right? And you require the caller to supply an array for the function to modify, right? So the caller passes in an array that's big enough for whatever they want it to do, or for whatever the function needs to do. The function returns the number of values in the array that were written into. Right? So you can also do that, or right, you can return the length of the array, right? So a function returns an array of size 100, the 100 gets returned. The caller specifies or provides a pointer to a pointer, right? Why do I need a pointer to a pointer, right? So the idea here is that the function is going to make a new array, right? And then it's going to write the address of the first element into a pointer, right? Remember, if the function wants to change something owned by the caller has to provide a pointer to that thing. So if the function wants to write into a pointer owned by the caller must provide a pointer to a pointer. Fun, right? It doesn't stop there, right? You can have a pointer to a pointer to a pointer. So star, 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 or a pointer to a pointer to a pointer to a pointer, right? 4 stars in a row, and so on, and so on, and so on, right? Fortunately for you guys, you're ever only going to see 1 star in this course, right? But in the real world, it's not unusual to see 2. It is somewhat unusual to see 3, a pointer to a pointer to pointer. Okay, so let's look at some examples of these types of functions. First option here. So what is this? Okay, so some function is going to compute some array and then return a pointer to the first element of the array. Right, so this is going to compute an array of int and return a pointer to the first element of the array. Right. How long is the array? So somehow this information needs to be communicated back to the caller. Right. This can't be a plain old int or a plain old size t object. Right. If it was, when the function writes into that object, into that value, the caller doesn't see the changed value. Right. So the caller has to provide a pointer to a size t object in this case. The function is going to write into that object using the pointer so that the caller can see how long is the actual array. Right. So the step that's missing here is making the array. So I'm going to show you how to do that in a lecture or two. Right. You're going to make an array of length, in this case, y. Now we're going to write the value of y into the object that was provided by the caller. Right. So the caller provided a pointer to that object. I can write directly into the object by dereferencing the pointer. Right. Then I can return the array. Right. So for example, here, what is this doing here? Oh, some func. Never mind. Why did I write it like this? This is silly. This is meant to say x square bracket equals some func, and then passing in some length. Right. Oh, here. Okay. All right. So what's the problem inside this function? Right. What you cannot do. Right. Notice that this line is missing intentionally. Is because if you try to do something like this, which is legal, it's fine, right? I can make a variable y, set it to 100. I can now make a local array of length 100, right? I can fill in its values if I wanted to here, or do something else, right? I can write 100 into whatever object is pointed at by length, and then return the array. This compiles cleanly, might compile with a warning, depending on your compiler settings. Right, but this will compile. It'll run. The problem is when the user tries to use the returned array, bad things will happen. Right. What is that? Right, that's a little local variable. Right. What is its storage duration? The length of the function. Right. So ARR exists at this point here. It no longer exists at this point here. Right. It has automatic storage duration. If you try to write a function like this and someone tries to return an array, almost certainly their program will do something unusual. It'll either crash or the results will be gibberish. Right. So here, some func is trying to return a pointer to an object having automatic storage duration. You can never do this safely. Right. The variable ARR no longer exists after the function returns. Right. So if you want to do something like this, and it's often the case you want to do something like this, right, you need to do dynamic memory allocation. Right. All right, that's what you need to know about arrays in C. Right. Notice they don't quite behave the same as arrays in Java, right? And they don't behave at all like lists in Python. They are a much lower level of, they provide a much lower level of abstraction than a Python list or a Java list, right? They're much more unsafe to use compared to a Java array. Unfortunately, that's what you're stuck with when you're writing in C. Okay, strings. Strings are just arrays. So this is more or less a review of the array of arrays. So a string is just a sequence of characters, and in C, the sequence of characters stops at the numeric value 0. Right. So somewhere in your sequence of characters is going to be a 0. That 0 indicates the end of your string. Right. The 0 is called the null terminator. Right. Its numeric value is 0. Right. Its char value is \0. Right. So inside single quotes, it's always \0. Numerically, it's just equal to 0. Right. We can ignore this stuff here. So we're only going to talk about what are called normal C strings. Right. There's other types of strings in C. Right. So the normal C strings can represent the English language just fine. If you try to represent characters in another language, you have to use a different representation for your strings. Okay, so a proper C string must be null terminated. Right. has to end in with a character that looks like \0. Right? Remember, the character 0, that's the printable character 0. Its numeric value is not 0. Right? The numeric value of 0 as a car is single quotes \0. So there's my car 0. Right? There's my null terminator \0. If you print them out as numbers, right, the numeric value of 0 is 48, right? So single quotes 0 is actually the number 48, right? Single quotes \0 is in fact 0, right? When you're working with strings, you have to remember you need a 0 at the end of your string. So if you want a string of length 9, you need an array of at least length 10. Okay, so here I've got S1 and S2. They're both arrays, right? They both contain A, B, C, D, right? They're not proper strings, right? Remember, a proper string, the last element would be a \0, right? So these aren't correct strings, but they are correct arrays of car, right? There's another reason why the C language kind of sucks, right? An array of car is a string, but a string's not an array of car, right? Sorry, an array, a string is an array of car, but an array of car is not necessarily a string, right? There's no \0 here, so these technically aren't C strings. If you try to print them out using printf and the %s conversion, right, something's going to happen. I don't actually know what anymore. I don't remember. Let's see. Oh, here, this is what happens. Perfect. Okay. So when I print out S1, I don't get A, B, C, D. I get A, B, C, D, A, B, C, D. When I print out S2, I get A, B, C, D, which is bizarre, right? Why does this happen, right? So what's going on here is that the way that the compiler has laid out memory here, right? I've got my array S1. A, B, C, D. But, right? No \0 here because I didn't put one in, right? And then when it laid out S2, it decided to stick it right beside S1. So S2 starts here, right? And there's an A, B, C, D here, right? No null terminator here because I didn't put one in, but it looks like by chance, whatever happened to be here happened to be the numeric value 0. So when you print out S1, it prints A, B, C, D. The way printf works, it's looking for the null terminator to know when to stop. Right? It doesn't see one, so it keeps going. So A, B, C, D. And then it sees the null terminator, and so it says it decides, oh, that's the end of your string. When it goes to print out S2, well, it starts here. A, B, C, D, sees the null terminator and stops. Right? So any of these functions that take in C strings are always looking for that thing there. Right? It doesn't find one when it prints out S1 until it goes past the end of S2. Right? There's no guarantee that your compiler will lay out memory the exact same way. Right? So on a different computer, this might print out something completely different. Here's another example of when things can go bad. Here I've got a structure. Right? Inside the structure, I've got an array of car of length 4. So I can safely store a string of length 3 in there. I have to remember I need a null terminator at the end, though. After the array, there's an int. The way the C standard works is it says the array S appears in memory. Right after the array is the int I. Right? There can technically be space between the array and I, but in this particular case, there won't be. At least not on my compiler. Right? Okay. So here, I'm going to make a struct object called temp. Right? I'm going to set the first element of my string to \0. So that's the empty string. Right? I'm going to set the value of I to 99. if I print out the string and if I print out the int, I had better get nothing and 99. Right? And I do, right? Empty string, I is 99. Right? Now, I'm going to set the first character of S to A, and then B, and then C, and then D. Right? I've got room for 4 characters. And then I'm going to go past the end. I'm going to write into the 5th character, I'm going to stick in a 0. Right? The null terminator. So I think I've done the right thing. I've null terminated my string. Unfortunately, what you've done is you've gone past the end of the array. Right? There's only 4 elements in the array. When you go to the 5th element, you're at the start of that int object right there. When you write a 0 into that int object there, it turns out, at least in this particular case, you end up writing a 0 into the int value there. Right? So without changing I is changed. Right? So I never accessed the member I here. Instead, I accidentally accessed it via the array. Right? So that's no good. Notice here that when you print the string, it actually prints out correctly. Right? So the null terminator isn't actually in the array itself. Right? The null terminator happens to be sitting inside the object I in this case, which is why it stopped printing after the D. Right? It's also why your object I is no longer valid, right? It no longer has its correct value. It should be 99, it's not, it's 0. Okay. Oh, sorry, we're over time. So I guess I'll stop there. Today is Wednesday. Okay, so on Friday, I guess is your test. I posted an announcement. I updated the announcement yesterday about what's on the test. There will be regular expressions, but the regular expressions are really simple that you have to write. Right? They're not complicated at all. I'm just testing, do you know what a regular expression is? Right? It's very easy to answer the regular expression question like this. I don't understand. Okay.